So in this video, I want to talk about the autonomic innervation of the eye. So let's first review what is happening if the sympathetic nervous system is activated regarding the pupillary aperture. So what you're going to experience is mydriasis, pupillary dilation. So when you're running away from the lion, pupils are dilated. Why does it make sense? Well, the sympathetic nervous system equips you for the worst case scenario. And after all, the lion could attack you in the dark. To be able to see in the dark, the pupils need to dilate because they want to collect as much light as possible. So which receptor mediates the pupillary dilation? It's actually the alpha-1 receptor. So we find alpha-1 receptor on this radial muscle here, which is called the pupillary dilator muscle. So when this radial muscle here contracts, so when the distance between this point and this point gets smaller, that means the pupil is going to be pulled out. So the pupil gets bigger and you're going to find pupillary dilation. The fancy term is mydriasis. So please note, to get to the dilation of the pupils, you need to contract a muscle. Unfortunately, this muscle is called pupillary dilator muscle. That can help us to remember the effect that this muscle is mediating. So let's look next what is happening to the pupillary aperture when the parasympathetic nervous system is activated. We know when we are in the rest and digest mode that we're going to experience pupillary constriction. The fancy term is mydriasis. Why does it make sense? Well, if you are resting and digesting and comfortable, we don't need to collect extra light. We just turn on our night lamp if we need to read. So how is mydriasis mediated? Well, we're going to have the contraction of this circular muscle here. So we're going to find a lot of M3 receptors on the circular muscle. And when this muscle contracts, we're going to have pupillary constriction. We know that the receptor that mediates this is an M3 receptor because we know for the parasympathetic nervous system, most of the effects are mediated by M2 and M3. And M2 is on the heart and M3 is everywhere else. So the eye is also everywhere else. So we're going to find M3 on this pupillary constrictor muscle. And fortunately, again, the name is going to tell us what is happening to the pupillae. So in summary, to mediate mydriasis as well as mydriasis, both times a muscle needs to contract. It's just a different muscle. The one time is this radial muscle, the pupillary dilator muscle that contracts and mediates the dilation because it pulls out the pupillae. The other time, it's a circular muscle that contracts and makes the pupillae smaller, the pupillary constrictor muscle. So let's finish up also talking what is happening in terms of the accommodation for far versus near vision. We know when the sympathetic nervous system is activated, we want to accommodate for far vision because we want to know if another lion is approaching us. We don't care to read a book right now. In contrast, when the parasympathetic nervous system is activated, when we are in the rest and digest mode, we want to accommodate for near vision because we are just busy with reading a book right now. The accommodation is mediated by the ciliary muscle. And let's start with the parasympathetic nervous system. As we know that most of the responses are mediated by M3, if we are not talking about the heart, we know that it needs to be a contraction of the ciliary muscle, as M3 receptors are GQ coupled. Most of the times, the parasympathetic and the sympathetic nervous system act as counterplayers. So if the accommodation for near vision is mediated by the contraction of the ciliary muscle, we can conclude that the accommodation for far vision, what we're going to see when the sympathetic nervous system is activated, is mediated by the dilation of the ciliary muscle. So just the opposite. And we also know that smooth muscle dilation is always mediated by beta-2 receptors in the sympathetic nervous system. So that lets us predict that the accommodation for far vision is a beta-2 effect. This concludes the video on the autonomic innervation of the eye.